And here we want to talk a little bit about work to embrace Kubernetes in OSM at multiple levels, some of which you'll see in R5 in terms of an experimental way to deploy OSM on Kubernetes, and some of which will land in R6 in terms of actually operating network functions on top of Kubernetes. So that's the heart of what we talk about. It's really these two propositions. Let's make it really great for people to stand up OSM on Kubernetes, and let's make it really easy to operate network functions on Kubernetes. Now those two go really well together because the sense that people have is that anything that happens on Kubernetes is going to be faster, is going to be easier, is going to be cleaner. The truth is there's a lot of complexity in Kubernetes itself. And one of the things we'll talk about this afternoon is some of the work that we're doing to kind of make it easier for people to get Kubernetes itself. But fundamentally, we should be able to provide people with an operating regime for OSM, an onboarding regime for OSM, and a sort of initial POC type experience of OSM, all of which is a lot more fun and a lot easier. So I should say that when we talk about Kubernetes, of course, there are lots of Kubernetes. Everybody's got one. We care about a whole bunch of different scenarios. We care about developers, people who are going to potentially start understanding OSM, integrating OSM, developing OSM, hacking on OSM. We care about people running VMware, so enterprise infrastructure. People get easy access to VMs on VMware. It's almost universally deployed in the enterprise and in telco IT type environments. We care about people operating on bare metal. If you look at a lot of edge cloud type environments, there's bare metal there. If you look at people's sort of research POC type environments, there's bare metal there. Anybody who's doing very data intensive, analytic intensive type environments, there's bare metal there. And then of course we care about the public clouds. We care about the public clouds in two different forms. We care about the public clouds as infrastructure providers, where you can go get machines and deploy stuff on those machines. But we also care about their Kubernetes, their dedicated Kubernetes SaaS offerings. So if you look at that market, obviously Google blazed that trail with the Google Kubernetes Engine, GKE. Azure followed with Azure Kubernetes Service, AKS, and Amazon then launched EKS, the Elastic Kubernetes Service. So you can think of the public clouds as essentially offering either raw machines or offering a sort of a dedicated Kubernetes endpoint with managed capabilities. And we care about all of that. That's what we mean by Kubernetes. Okay, so what is Kubernetes? Just a quick primer intro, although I suspect most people have a handle on this. Kubernetes is a distributed Docker runtime, right? Everyone's heard of Docker. Docker is a way of essentially shrink wrapping a machine file system, and some tricks to essentially make it efficient to distribute that by essentially just distributing deltas. If two machines have the same clean operating system image, someone installs an app on this, then when we ship that updated operating system from there to here, we can actually just ship a diff effectively across, and that makes everything nice and quick. What does that look like? Well, if you have a set of machines, right? Kubernetes is installed, log on Kubernetes. Kubernetes is installed on good old servers or virtual machines. A set of machines, call those the worker nodes. That's where all the stuff is going to run. Think about having an agent on each machine. That's the kubelet or the worker, effectively. And then think about having a control plane, which is the master. There's a little database there. There's some API services there. This is what people talk to when they're saying, I want to tell Kubernetes to do something. That then essentially instructs these agents to run Docker containers. And so here are your workloads, here are your applications effectively getting sprayed across those worker nodes. It becomes very difficult in that world to know exactly what's running where. That's really what Kubernetes does. It tracks all of those containers. As this cluster gets arbitrarily big, these guys can be spread all over that. They can be terminated arbitrarily on one machine and restarted on another machine. You lose track of where the workloads actually are. So that's what, roughly speaking, Kubernetes looks like. And we're talking about essentially operating OSM on top of that, and then also having network functions on top of that or on top of different Kubernetes clusters, and having OSM command and control those network functions. Okay, so what is the easiest way? You know, if we think of all the different markets we're trying to reach, I think the most important one is the people who start out quietly in their own, on their own laptop, or quietly in a cubicle, or quietly when they have some spare time and they just want to try OSM, right? So for me, this is a really important question. What's the very easiest way, if we're going to introduce Kates into the onboarding process, what's the very easiest way that we can basically make that a no-op so people can then get straight to the good stuff, which is OSM. So I want to show you something called microkates. This is something that we, Canonical, have been working on, and we've been working on it with Google in the context of some AI work. Same problem, right? How do we make it really easy for people who want to work with AI tooling on top of Kubernetes to just get up and running quickly? Well, we don't want Kubernetes to be complicated. We want Kubernetes to be just a one command thing, and then they can get to the good stuff. In that case, it's AI. In this case, it's OSM. So what's microkates? Microkates is a single package install. So it's one command install on most versions of Linux, right? Obviously, we care most about Ubuntu, so we derive it hardest on Ubuntu, but it also works on Fedora, CentOS, works on OpenSUSE, a bunch of different Linuxes. If you go to snapcraft.io, that'll tell you how to install snapd on your Linux, and then it's snap install microkates. It's useful for a single VM or a single workstation or a single appliance. People are using it for microkates for IoT, for example. If you've got a CPE, a single box, a top of rack switch, a robot, right? It's never going to be elastic. You're not scaling out the cluster effectively, but you do want a Kates there on that box. Then microkates is really nice, because on that box you just say, give me microkates, and you'll get upstream Kubernetes in one command. It tracks upstream releases, so actually you'll find you can get microkates version of Kubernetes 1.11 and 1.12 and the 1.13 and so on, and point releases of that. So if you've installed 1.11, then you'll get 1.11.1, 1.11.2, 1.11.3, and you can hook it up to this, what we call an edge track, which means when upstream builds a new commit, which happens fairly frequently with Kubernetes, it will be downloaded to your machine. So you can really track upstream Kubernetes. You can get the latest Kubernetes. It's very nice for people who are either trying to track the latest stuff as developers, or wanting a stable version for production type usage. Supports upgrades to the major versions, so 1.11, 1.12, 1.13, and so on. It's fast, it's small, it's a 200 meg download. That doesn't sound that small, but if you look at deploying Kubernetes, it can get a bit monstrous. So it's pretty tight. And that's the install command. So if you have an Ubuntu 14.04, 16.04, or 18.04, standard LTS releases, or any of the equivalents from the sort of Fedora, CentOS, Debian world, then it's that command to get microkates. I think we can demo that. And you want to expand the font.
Yeah. So, if I look here, I only have 2 snaps as AWS and Core. And for installing, and it's done.
So that's Kates install. Now, that was cheating a little bit, because there's a 200 meg download, but you can pre-cache that. You can essentially say, go do that download, and then the package is effectively locally available, but not installed. So it's very fast, very clean. Snap list will now show it. Right? And if you say, you can see you've got a Kubernetes up and running. So you can do that on a laptop, you can do that on a VM in the cloud, you can do that on a bare metal machine, you can do that on a VM on VMware, and you get Kubernetes. It's a very nice, clean way to say, find me a machine and just give me a Kubernetes. Right? It'll never scale. You're not going to go cluster them, but you'll just get a Kubernetes and go. you might just want to snap install Hello World or something. Let's see the full snap install experience if you do hit the store. So there's normally this sort of a download process like this. And then that's what you saw previously from microcates, right? So it's very clean. And then microcates itself is a pretty complete Kubernetes. So it supports things like Istio. Oh, all right. So those are the different channels. The way the snap packaging system works is the publisher, in this case it's essentially CNCF, can publish simultaneously different versions of the software into different channels. And you, when you install, you can essentially subscribe to a channel. Just saying install gives you essentially latest stable, which currently is 112, revision 238. The publisher can change that at any time, right? So the publisher can say, okay, for 112 beta, I want to put 112.1 beta 1. And then if you were subscribed to that channel, you would get that version. So that's how you essentially select which version you want. That's pretty nifty. And so then there's the enable help on microcates. So the microcates package is kind of like a wraparound Kubernetes and has some helper functions to do things like fire up a Docker registry on that microcates. You can have your own little Docker registry there. Launch things like Istio. Folks familiar with Istio? Configure the storage, map GPUs into that microcates. So say you've got a nice machine that's got a GPU in it, you can snap install microcates and then pass a GPU to that microcates. Now you can run AI machine workload type machine learning workloads on top of Kubernetes, and they can bind to that GPU. We could extend this, for example, to do a bit of SRIOV or other kinds of PCIe pass-through and so on to be able to get special capabilities from the underlying machine up into containers running on top of Kubernetes. Dashboard, I think, is just the standard Kubernetes GUI. DNS is what? DNS core.
Yeah.
So those are all sort of pretty typical things that would normally take a little while to set up on Kubernetes. But you can just say microcates.enable those things and they get spun up on your microcates. So there you have is like on a developer laptop or a VM or a machine, cates in one command effectively. Any questions about that? Because that's going to be a really useful primitive for us in a number of areas.
And
yeah.
You would actually run, use the micro-8 to basically deploy the container, for example, that holds your OSM.
Yes, so what we're going to show now is, all right, if I've got a laptop, if I'm just trying out OSM, microcates, and then deploy OSM onto that Kubernetes, right? So that's what we can do. But we can also use the microcates here for example, if I'm a network function creator, provider, I can iterate my network function on an aeroplane, right, using microcates on my laptop. So, and I can actually iterate the VNFD for OSM on top of all of that as well.
Oh, okay.
This is where we're headed, and that will be in OSM R6.
Okay.
Yeah. So, okay, now we've got a Kubernetes up and running on the developer workstation. We want to go and deploy OSM. But OSM actually has quite a lot going on, right? So here's a picture of R5. This bus is software, right? We need to stand up Kafka. Poll and monitoring, what are those? Modules.
Yep.
Software. RO, that's a piece of software. VCA, that's Juju, that's a piece of software. LCM, that's a piece of software. NBI, we've got databases, we've got all sorts of things that we have to stand up on top of Kubernetes to have OSM on top of Kubernetes. So let's kind of think that through. We have inside OSM, we have something called VCA, and the job of the VCA is to keep track of pieces of software, right? So let's bootstrap, since we have to have the VCA anyway, let's bootstrap OSM using the VCA. So go into this, let's stand that up, and then use that effectively to stand up the rest of OSM. So again, on a laptop or in a workstation type environment, we stand up the VCA. Then we stand up microcates. And then we use the VCA to essentially stand up OSM on microcates, right, as an orchestration. And now we've got OSM with the VCA and the Kubernetes so that we can start actually having fun with network functions. So I think we can demo that. So what do we have now?
Okay, so now we have an empty Juju. So we have an empty Juju, and if we look at Kubernetes, we see we have an empty Kubernetes. And we have a deploy script. Normally we would handle this with bundles. That support is coming. But essentially, very similar to how the installer today works is it has to pull images from Docker Hub. So here we've just defined the list of what those images are. We'll say we're going to name a Juju controller with the model of OSM, and we're going to use microcates. This line here, this here is just feeding your Kubernetes config. So kubectl config view into Juju that says treat this Kubernetes as a provider.
So essentially teaching the VCA about a Kubernetes, right? So we've got the VCA up. First thing that the script does is say, hey VCA, there's a Kubernetes over there, and here's a credential to talk to it, right? That's this. Make a blank canvas on that Kubernetes. Prepare effectively storage. If these containers need disks for databases and disks for assets of various types, that's how you're going to get it from Kubernetes. You're just going to use the microcates host path, which is just the disk of the machine, right? Here you've got storage being set up, and then a series of basically deployments of the components of OSM.
And all these components will sit in one container?
No. So the way Kubernetes works is you want each different piece of software to be in its own container,
okay,
with its own image, because it allows you to scale those independently.
So these the boxes that we saw, like each one would be its own.
A separate container. Could be a different operating system in that container,
okay,
right? But Kubernetes will track all of that. And Juju will keep track of how many of them there are and configure them to talk to each other effectively. Yep.
And the benefit of this is what, like you mentioned, just I missed that one. You said this will allow you to scale?
Yep, so the independent components can now be scaled independently. So if I've got a database process, I can run 2 of those or 3 of those. If I've got a front end process, I can run 2 of those or 3 of those or 5 of those, right?
Maybe for maintenance as well, you can bring.
Precisely. So when I do an upgrade, I can effectively bring up a new version, kill an old version, bring up a new version, kill an old version. And that will all get handled by OSM, talking to the VCA, talking to Kubernetes. Yeah. And so here we're essentially doing what the VCA does, which is say I want to put an app on that Kubernetes, then I want to put another app on that Kubernetes, then I want to put another app on that Kubernetes, then I want to connect those apps together effectively, tell them about each other, right, and configure them. So let's just kick it off. I think that's the fun part. So here we're essentially building that model of software. It happens to be OSM that we're building a model of. And the VCA is talking to Kubernetes and essentially saying, okay, for all of these different components, I want you to go and fetch all of these different Docker images, pull them all together, stand them up, and configure them to know about each other so that OSM will be available to us. Okay, and if we do a Juju status. So that's what the VCA is tracking. Do you want to shrink that a little bit so that it flows nicely and we can watch it? There's a Right, so this is the model in the VCA. As the various components come up, they're talking to each other. So these different pieces of software are learning about each other and exchanging credentials, figuring stuff out. Going through different states, you'll see messages happening over there. This is the higher level view. We could watch what's going on in Kubernetes as well. So this is the stuff that Kubernetes is tracking. And you'll see that that's changing as these various containers get started. So you've kind of got a VCA view of what we want, and then underneath that you've got a Kubernetes view of what's actually running where. We can switch back between those.
Yeah, so we're going to say now where everything is deployed. Workload messages are still in flight.
Okay, the messages haven't been updated, but at the end of the day, it's done. So OSM's running. So what about large production environments? So we talked about all these. Yes?
Basically, created automatically all the Kubernetes, the descriptor files from the Juju commands. That's what you did?
Yes. You look like a man who's had a bit of Kubernetes FaceTime. There's no YAML here. So that's what the VCA is doing for us. The VCA has got this nice ability to essentially say, okay, I understand applications, I understand scale, I understand relations, and all the complexity associated with running a particular application on Kubernetes, that gets stuffed into the charm. So the charm is typically Python, and that's where, you know, smart DevOps can work effectively. But the beautiful thing is, the actual operators don't have to really understand how that stuff works. They just can use it, right? So they don't really have to understand Kubernetes, and they don't really have to understand the applications either, because the charms effectively capture that knowledge, and they even capture knowledge of integration. So, you know, different people using software integrated with other components, as long as that work's being done by someone in the community or some vendor that cared about that piece, they don't have to know anything about that. They can just use it. For people who are familiar with Kubernetes, this is really surprising, because as much as Kubernetes is touted as being super easy, actually it requires you to understand a lot of tricky little pieces and line them all up and get them exactly right. That looked easy because the charms effectively are driving Kubernetes. The charms are written by people who know exactly what they're supposed to be doing, and so it looks easy effectively. Right, so what about larger production environments? We talked about, I think the first one we hit was GKE.
Yeah.
Yep. So GKE is interesting because it's the Google SaaS of Kubernetes. So it's about as opinionated an implementation of Kubernetes as you can get, right? You go and ask Google for a Kubernetes, they give you a Kubernetes. It happens to be on Ubuntu. In other words, Google now by default, I think, uses Ubuntu to provide the Kubernetes in GKE. That's the operating system underneath it. But it's all Google effectively. All the Kubernetes bits, all of the operations of that, that's all, you know, just SaaS from Google. They control the whole thing. But it works very well. This is the Kubernetes container model. So we just did exactly the same thing. Essentially, Juju deployed OSM on GKE, or asked GKE for a cluster, a Kubernetes cluster, connected Juju to that cluster, ran the same script effectively, get the same set of containers, right? Obviously different IP addresses. And then I think we can show the UI and whatnot.
And this should look very familiar to everyone.
So that's all running on GKE. And then if we switch to AWS. So on AWS, we decided to use the charmed version of Kubernetes. So to deploy Kubernetes itself using charms of Kubernetes. So we're using the VCA to build a Kubernetes out of raw Ubuntu machines, right? So we just go to Amazon and say, give us a bunch of Ubuntu machines. Here they are. The VCA fetched them. And then let's deploy charms of Kubernetes. Now those are machine level charms. Those are similar to the sort of proxy charms that you will see tomorrow. But they're installing etcd, they're installing a key management system, they're installing Kubernetes masters, they're installing Kubernetes workers. This looks like it's scaled out over a couple of machines. So you've got 3 worker nodes in your cluster, you've got 2 masters, you've got 3 etcds. So a nice sized Kubernetes that's been built with Juju on Amazon. I'll show you what that feels like if you want to do it yourself. So now we've got a Kubernetes. It's a clustered Kubernetes on AWS built by the VCA. We can tell the VCA about it. Where's that? We tell the VCA about that. Then we can create a model on top of that Kubernetes and deploy OSM on top of that Kubernetes. And that's this model over here. This is the Juju model, right? And the kubectl on that. So it's interesting. So here you have the Juju. This is the output of the VCA describing its different models. This is the model where Kubernetes got built on Amazon. In the same controller, this is the model where OSM got built on top of that Kubernetes. So the same, essentially, VCA is able to track all the software that's making Kubernetes, and it's able to make a new canvas on top of that, and track all the software that's OSM on top of that Kubernetes. And that is the Kubernetes view of OSM running on AWS.
And if we look out here, there's the UI running on AWS.
Also awesome.
You mentioned something, I'm not sure if I heard it correctly or not. You mentioned that on the cloud, each component, you deploy it in one container, or is it in one?
I'm going to, so
Yeah, just not sure.
I'm going quite fast, and we've done something maybe a little too clever. Amazon, AWS, will give us VMs.
Right.
So what we did is we got 10 of those, and we built Kubernetes across those VMs using the VCA. I mean, the VCA's job is to understand applications installed on machines, right? Command and control and configure them. The applications that we deployed on these machines make up a Kubernetes.
So each machine you deployed one KAS, or?
No, so a Kubernetes, maybe go back all the way to the slides.
Yeah.
This slide, right? This is a Kubernetes.
Yeah.
I need some VMs to provide the control plane.
Yeah.
There's a database there called etcd. There's some software to keep track of IP addresses. It's like a sort of an overlay SDN. There is some key management software to essentially generate keys and hand them to the different components so that they can talk to each other
So
securely.
these are the workers, yeah.
And there's the workers, right? That's a piece of software.
Yes.
And all of that software needs to be modeled. In other words, I need to know what I want. I need to know what to integrate with what.
Sure.
That's all captured by the VCA, effectively. That's all described to the VCA. So it comes up very nicely. It's that same experience of other people have written all of the command and control software. So for you, it's very easy, right? The net effect of all of that is that on those 10 VMs, there's an IP address where I can connect to the Kubernetes master, this guy, right? So I've built a Kubernetes.
Yes.
It's wrong to say the Kubernetes is running here or here or here or here. It's a Kubernetes. It's a distributed Kubernetes. In fact, we can go make it bigger. Do you want to just scale it out? Do you have quota?
No.
Sorry, we can't afford to scale it out. But basically, if we just go to Juju, if you just go to Kubernetes and type the command, it'll try, right? So if you just do status, and you'll need to make the font bigger.
Scale?
Where are the machines?
Mm-hmm.
I think you need to switch actually to CDK.
CDK.
Right, so this is the model of Kubernetes in the VCA. And because it's a machine model, it's built out of machines, not Docker images,
Okay.
right? The first thing it tracks is a number of machines, 0, 1 through, right? Then it's also tracking, if we scroll up, it's tracking how the applications are mapped onto those machines. So the applications are these things up here, and each application might actually be installed in multiple machines. We call those units of the application, right? So if I've got a database spread across 3 machines, I've got 1, 2, 3 units of that database, and they learn about each other, and they can talk to each other through Juju, right? So that's what's modeled here. If I say to Juju, I actually want more workers, the command to do that is add unit. I want another unit on the Kubernetes worker, so we can go and type that. Add unit Kubernetes-worker. Right. But you need to do it on the CDK. No, you just switch. Yeah. Because this Juju has multiple models, we need to issue that command to that model over there. Right, so what's happening now? We've asked for another unit of Kubernetes worker, right? It's waiting for a machine. You find a machine for it. If you come down to look at the machines, machine number 11 is pending. We've gone to ask Amazon for the machine. Basically said to the VCA, we want more workers in the model. The VCA says, need another machine. So it's gone to ask for another machine. But then we think, add a mode of quota on Amazon.
How are the machines tracked?
In Juju.
In the end, though, is it just an IP address?
Yeah,
Well,
I
let
mean,
me
it's a
re-ask
hand-
why I'm asking.
It's a UUID effectively from Amazon.
Can this list be physical machines?
Yeah. I'll show you
Doesn't
that
have to
later.
be VMs, right?
No, I'll show you that later. So what's happening now is that we've mutated the model in Juju to say we want a bigger Kubernetes. We're using Juju as a sort of RO in this case as well, right? So it goes to the cloud and says, okay, give me another machine like the last lot. And that may fail because we don't have quota, but if the machine came up, then Juju would go into that machine and say, okay, you need to be another Kubernetes worker. Because in the model here, right, this Kubernetes worker 3 unit, it's the number 4, 0, 1, 2, 3, right, will be allocated to that machine. Is it coming? Looks like it's coming.
I think so.
Yeah, it might have quota after all. So actually what we've done right now as we're working is we're scaling out Kubernetes. But that Kubernetes is already running OSM, right? So in fact, OSM is busy running on top of Kubernetes while we're making the Kubernetes bigger underneath it. It's quite nice. Okay, so we did GKE, we did Amazon. On GKE, we used Google's Kubernetes. On Amazon, we used the upstream charmed one, that you could operate through Juju itself. But the OSM deployment on top of Kubernetes was the same both ways, and the same as the microcates experience. And so the last one we wanted to show you was MAS, right?
Yes, we need to make Mark the presenter.
What's that?
We need to make you the presenter.
Okay, so I have a MAS, a Metal as a Service, in my garage. And Metal as a Service basically is like a system that does PXE, IPMI, DHCP, DNS. It gives you essentially physical machines on demand. You can say, give me that physical machine with Windows. You can say, give me that physical machine with Ubuntu. You can say, give me that physical machine with ESX. And so essentially it just handles the physical provisioning layer in the data center. It's not opinionated about what you actually want to do with that once you've done it. But of course, Juju can then go to that and say, okay, give me machines for this purpose.
You just need to share your screen.
No, add the Chrome extension. Yeah. Yes, root my box.
Okay, now you're sharing.
Right. Right, so this is a list of machines. You see only one of them's on, right? And if I switch to this view here, you see I've got a Juju running, and in this default model over here, I'm going to say what's running there, nothing. If I say Juju deploy Kubernetes core, it builds the model effectively. Goes and gets the charms for the various things in Kubernetes. It essentially gets two machines, and then it maps all of those pieces of software to those two machines. And if I say, right, show me what the model looks like. This is the bare metal equivalent of the Kubernetes that we showed you on AWS, but it's a shrunken one. Two machines, one with a container effectively where I will put the key management thing. And then here's my set of application units. You can scale that out. So now I've said, give me a couple more workers and a couple more of the database. And so now it's going to go and get those machines from MAS effectively, which is over here. And you can see them turning on. See the machines being turned on effectively. The operating system will be deployed. That's very similar to going to the cloud to fetch them, right? So we're building a Kubernetes now out of bare metal. It takes about 15 minutes. Once we have Kubernetes, of course, we can then tell the VCA about that Kubernetes, and we can then deploy OSM. So this, in half an hour or so, is a bare metal Kubernetes running OSM, and we can then use that Kubernetes for deploying network functions. So I think let's move on to the network function deployment story. We intend to test OSM with all of these different kinds of Kubernetes. On VMware, the Pivotal Container Service, Azure, Canonical Kubernetes, which is the charmed Kubernetes, OpenStack, MAS, we showed you bare metal, Amazon, Google Cloud, all of the major public clouds, all of the major enterprise infrastructure, and VIMs effectively, and bare metal. If there are any others that people care about, we should add them to the testing regime. It's really easy to do that. Okay, so looking forward, in OSMR 6, we should now have the ability to operate with OSM network functions on Kubernetes. I mean, what have you seen? You've seen the VCA running software in a very nice, easy way on Kubernetes, right? And providing a nice, clean interface to all of that. So why can't we use that for network functions? So the VCA now supports native Kubernetes network functions. The VCA, Juju, provides model-driven operations. And that's a very nice fit for Kubernetes. You know, with the VCA today in OSM, we use it in a slightly awkward way, but as we move towards Kubernetes, you'll really see what that VCA can do. Right, so what does Juju actually do for us? It essentially says any piece of software that we want to operate, we turn that into a reusable component, but a reusable operational component. You know, Docker will give you the app. The charm gives you the operations of the app as code, and most importantly, as code that can be shared by lots of different operators because the code is blind to where it's being used. There's nothing hard-coded in the charm that comes from one telco's network or comes from one bank's network, right? It's a shared piece of operational logic that's very cleanly separated from how you want to use it. You can think of it as like object-oriented operations. It's probably the best analogy, right? If you think of Chef and Puppet and Ansible as being a little bit like go-to, right, basic programming, where you can kind of do anything, but you've got to jump to here or jump to there, it becomes a bit of a, something that one person can love in their environment because they know how it all works. But it's very difficult to reuse portions of somebody else's basic program, right? Object-oriented programming introduced this idea of saying, well, let's make something that's reusable, and all of the logic of that stuff is kind of encapsulated in that object. So Juju essentially does that for system administration, software operations. It says, let's make an object that represents a piece of software and the operations of that, so that everything else doesn't have to know how that works, it just has to know how to talk to it, right? And then over time, that thing can get better separately from this thing. Standardized operations, architecture independence. What do we mean by that? Imagine, if you think about somebody deploying a little database for test and dev purposes, a little MySQL, and somebody deploying a big MySQL. Well, actually, to back up that MySQL is exactly the same, right? The architecture doesn't matter, right? The operations are the same. If we can abstract them from the particular deployment, we can get better and better and better every day. Repeatable deployments, multi-cloud, multi-vert, bare metal. Essentially, we don't want to care, or we want to be able to reuse this stuff in as many different places as possible, because things like security will then get better and better because everybody's using the same stuff. When someone finds a security bug in the operations code, that gets fixed, and it gets fixed everywhere effectively. Scale-aware topological modeling. You saw that, right? You saw that we could scale the functions nicely. We track what the scale of a particular component is. We can add to that scale or shrink the scale of a particular component. That's all tracked in the model. And topological in the sense that we related things to each other, right? We have this thing, we know that this thing's integrated with that thing, right? And that's the topology effectively. And it lets us essentially have standardized ways to do upgrades and integration automation. Those relations effectively are lines of integration. So this is a canvas, it's a blank canvas, call it a model. And then in there, say, right, we want to deploy an application, but we never really deploy one piece of software anymore, right? We actually deploy lots of pieces of software. Those are applications to Juju. And perhaps most importantly, we integrate those pieces of software. We decide this piece of software should be talking to that piece of software, but this piece of software should not be talking to that piece of software, right? So Juju, the VCA, understands that idea, and it is designed to allow integration work to be reused. So if someone's made this application work well with that application and automated that, then somebody else can essentially very cheaply just say, use that automation. I want to integrate those two pieces of software. I think in the telco environment, this is a key idea because in many telcos, the fact that they've manually integrated two pieces of software now traps them to using those pieces of software, because to use something else would mean redoing that work. But if that integration work is effectively packaged and delivered as part of OSM, then it becomes much cheaper for telcos to evaluate different things, try new integrations, move fast. So we track integration as relations, and then we track scale through the idea of units, right? And we have the idea that these are peer units of each other, and those, because they're related, those are counterpart units to these guys, right? And units talk to each other across relations. So when I relate this application to that application, these units, who can talk to each other always as peers, now they gain the ability to talk to those units. What do I mean by talk? Really mean exchange operational messages. So that, for example, if that guy wants me to use a particular cryptographic key to talk to them, then they can send me their public key and I can then use that to talk to them, right? So essentially, all the figuring out of how these guys should most efficiently talk to those guys is handled across those lines of integration, the relations in the model. Here I'm trying to show that we separate the operations code, which handles things like how do I install the software, how do I start the software, how do I upgrade the software, how do I configure the software, and so on and so forth. We separate that logic from the actual software itself. This gets bundled up into something called charm. It's just a zip file of code that understands this software effectively. It's organized by event handlers, right? And then the application could be delivered lots of different ways in different sorts of environments. So what does this mean for OSM? Because Juju, the VCA, is built into the OSM architecture. It allows us to use that modeling concept. And one of the things that I think is really interesting about OSM, we'll see this very clearly in R6, is that we're going to be able to operate in a sophisticated way in environments that include 4 completely different generations of network function, right? PNFs, physical network functions, appliances racked in the data center. How will we operate those? Well, and OSM does this today. It feels kind of awkward, but in the long run, it's actually going to be, I think, quite useful, right? We make a space in the OSM machines to put charms there. Those charms can then program these boxes over the network. So we call those proxy charms. You'll run into them tomorrow for those of you who are on the hackathon track, but they feel kind of awkward in that context, but they're useful in the sense that it's very hard to install software in these things, right? These things are black boxes. Can't really put software there, so we have to find a space somewhere to put software, which is the logic to program them when OSM wants to do something. So that's what we use proxy charms for. So the first generation of NFV was to take the disks out of these and say, okay, let's make those VNFs. They're still kind of awkward in the sense that they're still kind of, it's difficult to install software in them sometimes, right? This might be QNX, this might be, DOS, who knows? We can't necessarily go there and put software there, but we can poke at it over the network, just like we can poke at this over the network. So again, we can use proxy charms for this kind of this kind of situation. Sort of first generation NFV. In R5, we're getting what I would call cloud native, in the original sense of cloud native, network functions, cloud network functions. Now, how do a lot of people work on something like Amazon? By default, they'll get clean images of the underlying operating system. A clean image of Windows, or a clean image of Ubuntu, or a clean image of CentOS. And then they install the software on there using things like Cloud Init. They take that clean image and they bootstrap it effectively. And what do we do to turn this clean image into a network function? We essentially put the charm there in that image, and it can install the app there in that image. So this plain OS image becomes a network function effectively. And we can do that a couple of different times, and so we end up with a bunch of VMs that have been kind of marked up from being known good standard OS images into being network functions. And again, to OSM, that's just a model for the VCA to handle. The RO will go and fetch these base images, and then the charms will effectively go and fetch the software and build the software and configure the software. That's exactly what we were doing over here when we were building Kubernetes, right? We're just fetching Ubuntu, in this case, Ubuntu machines, and the Kubernetes charms we're installing Kubernetes apps to turn them into Kubernetes functions to make a Kubernetes network scenario, right? Right? And then in R6, we gain this next piece over here, which is this idea that we could have Kubernetes network functions. Now we don't have machines anymore. The network functions are Docker images, right? Where do the charms go? They become what we call operators, in the Kubernetes term, operators. They are also Docker images, right? Instead of putting them over here as proxy charms or installing in the machines, remember the machines are now down here. Actually what we do is we just run another Docker image on top of Kubernetes, and we put the charm there to drive the application images, the application Docker images effectively on top of Kubernetes. This is what the code in the charm looks like. It's a lot cleaner than what you would see with proxy charms, because in a sense, everything's sitting on Kubernetes. The set of operational dynamics is more limited. Actually, that's nice because effectively it allows you to write much cleaner code to do various standard operational things like make more of it or reconfigure it and so on and so forth. And a lot of the work gets handled by Kubernetes. We're really just essentially, ultimately, going to issue commands to Kubernetes. The logic of what kind of command is going to be in the charm. So for example, if I'm running a database on Kubernetes, over the relations in Juju, I'll figure out all the keys that I want to use to essentially talk to the things that are talking to my database. And I'll figure out, for example, which disks I want to be in and things like that. Then I'll bundle all of that up into a command that I'll issue to Kubernetes to start the containers and feed them the big pile of YAML that you need to feed them, right, in order to do that on Kubernetes. And I think there may be time this week to actually give you a taste of that, so you can go home with a sense of, all right, this is what it feels like to write a charm as a proxy charm. This is what it feels like to write a charm when I can actually install the application on the VM. And then this is what it feels like to write a charm when my application is going to be just a Docker image effectively on Kubernetes. I think that's that. Any questions? Mike, how's that look? It's nice. Yeah.
Did you go over, did I miss it, how you use physical machines? So I'm thinking about, a small rack in a base station where you would want physical machines.
So this is my small rack in my basement, effectively. I built a model in Juju for Kubernetes, and I said, okay, deploy me a Kubernetes and scale it out a little bit. That model required some physical machines. So the VCA Juju went to MAS, Metal as a Service, and said, give me some physical machines. Those physical machines are these ones that are now switched on, right? These guys here, and that guy there. If I built, so now you can just see the ones that are deployed, right? And then if I go to the Juju view, you can see that what's happening is the machines got turned on, the operating system got deployed, that was all by MAS. Juju then, MAS then handed those machines to Juju, which is essentially installing the charms on those machines. The charms are then now installing the Kubernetes software. So that's what's going on over here, right? These pieces are now all slowly coming up. We're nearly there, actually, by the looks of it. Because this is running across lots of different machines, lots of stuff can be happening at the same time, and those messages are all coming to Juju and getting surfaced here in one view. But you'll see this is kind of coming into focus. This is telling you, for example, on this machine, this charm is executing right now. It's updated its status to idle. It's blocked. Why is it blocked? It's waiting for a relation to a certificate authority. Where's the certificate authority? That's easy as RSA. Easy RSA is on this LXD container. This LXD container is started, so it's coming. It's coming, it's coming, coming. This is Juju essentially keeping track of all of those different charms, tracking all of that different software to build the Kubernetes on bare metal. These guys have now been related to the key management software. The key management software is now up, so they're requesting certificates. It's really getting close. And now we're configuring the workers. We're configuring the masters. I think the masters will go next. And you saw what that command was like. It was Juju deploy Kubernetes core, Juju add unit to the Kubernetes master, to the etcds, Juju add unit to the workers. That's all I did. All of the complexity of standing up Kubernetes is encapsulated in those charms. Juju doesn't actually know what those charms do. It's just passing messages between them. And it's up. It's good timing. Waiting for that to finish. But it's all green. I suspect that Kubernetes is up. One last round. These are output messages from the charms effectively, just so that, on that machine I can see what's going on. It's sort of like a very high level view of the log. I suspect it's just going to restart the master, and then the workers will get connected. And that's all on bare metal. Once Kubernetes is up there, I can tell the VCA about that Kubernetes, and now I can deploy OSM on top of that Kubernetes. I can tell OSM about that Kubernetes, and then in R6, we can put network functions on top of that. And then that's all on bare metal.
Yay-boo.
Nice, huh? We can make it drive Wind River too.
Sure.
You know.
Yeah.
And obviously, Kubernetes containers with Wind River as an OS, those will work straightforward. Any questions?
If you think about this another way, what he's effectively just done is bootstrapped a bare metal edge with Juju, and thus you could do it from OSM. You could orchestrate these edges from OSM. You have this capability today. That's pretty powerful, being able to bootstrap an image, a bare metal edge, completely touchless from one centralized orchestration plane. That's pretty cool. I'm impressed. I don't even work for Canonical.
So those workers are now running, and they've got endpoints. We're just waiting for the master to settle down. And I used a slightly older version of Juju on here. Otherwise, I would go and try and deploy OSM on top of that. But we need Juju 2.5, which is still in beta, to get the Kubernetes models effectively. So, not quite there. It's great.
So, Mark, one question. What are the limitations right now for, that'll be in R6 for Kubernetes network functions? I know in the past that Kubernetes had limitations where you can only have like one interface on a container. And so, like, if you look at traditional DNS, they have a lot more. So, like, in your view, what are the current limitations, and, which of those will be fixed a couple of years from now or 6 months from now, whatever?
So the question really is just how ready for network functions is Kubernetes really, right? And the answer, I suppose, is it depends on the network function. There are a ton of vendors out there who will say, I've got a VNF for Kubernetes. It's not really a VNF at that point, but it's a network function that is designed to run on Kubernetes. For a ton of core functions like IMS type functions and so on, there's no real dependence on very complicated networking. You build the Kubernetes cluster on the particular network that you want, and then you would just run the apps on top of that Kubernetes and they're on the network.
Somebody might say, look, I need like 3 distinct networks, like ingress and egress and a management.
Right.
They have to be fundamentally distinct.
Right. Kubernetes does come from a Google-esque type view of the world, where you would typically say, look, I don't trust any of my networks, right? State actors could be in any of my networks, so I don't like the idea of having a physically trusted network because I don't trust any of my networks. The problem with that view is that you then are too relaxed about a network because it's called the secure network. It may not be secure at all, right? So in that mentality, you tend to do a lot more kind of access control and permissioning, role-based ticketing, and so on at the level of individual requests getting passed, between services, between microservices. So culturally, there is a bit of a disconnect between the kind of Kubernetes Google view of the world and the traditional telco view of the world. Clearly, the telcos have decided Kubernetes is a fun thing, and they really should have some of that, and they should tell those Google people, what a real network looks like. And so there's a bit of a cultural fight in there. It will shake out in the end that everybody gets most of what they want. You will be able to deploy, Kubernetes with more sophisticated networking, attach pods to different kinds of networks, and so on. Pods are the Kubernetes term for the clusters of containers on top of it. I don't think we need to worry about that. From an OSM point of view, it's very clear that the audience is excited about Kubernetes, despite the limitations. And so if we were able to go very fast and show very clean operations and integration of network functions on Kubernetes, that will be appealing to the audience, right? And then the rest is sort of details.
Sort of
you know.
fix it.
Yeah, exactly. Enough people care and it'll get fixed.
Well, yeah, but what do you like see right now as the limitations? Like if somebody was going to go build apps, I mean, that's one of them, the multiple interfaces, at least in older versions of Kubernetes. I don't know if there's any other ones that you see as showstoppers right now.
Yeah, I'd say having like multiple networks is probably the thing that's the most jarring. For a while, it was quite complicated if you wanted to pass hardware through. So if you think about it, if you have a GPU
Yeah, I mean, I think that one's
underneath all of this, or an SRIOV,
right.
handle down here, you've got to pass that to a VM.
Sure.
PCI you pass through, Vim, and then you've got to configure Kubernetes, and then you've got to say to Juju to tell Kubernetes to start a container on a machine that has one of those and pass it into the container. But for example, we're doing that now for machine learning, right? The GPU case is typically for machine learning. People are saying, I'm buying tons of GPUs, putting them in racks. I want to give them to people, but I don't necessarily want to, give them the whole machine. If I've got 6 GPUs in there, I just want to be able to give them VMs and then bind the GPUs. It's the same basic problem as what you would get with SRIOV. So I suspect if you really wanted to get to the cutting edge of stuff, you'd find that you're ending up with custom builds of Kubernetes with hacks to make stuff possible. But over time, I imagine what people need will come. Yeah. Anyway.
How does VCA in this scenario scale? Because you are deploying OSM over Kubernetes. So scaling all the other components is trivial. But how does VCA itself handle?
So in Juju 2.5, which is currently beta 3 and due when it's ready, we will get the ability for Juju to know about a Kubernetes and put stuff on there. That's what you saw. That's what we were using here to do all of this. In Juju 2.6, in 6 months' time, we'll get the ability actually for Juju to bootstrap on Kubernetes. Juju can scale perfectly well itself as a set of VMs. So what we're doing at the moment is, there's your Vim. We're bootstrapping Juju across, say, 3 VMs so that it's HA. And then we're using that to make another set of VMs. We call this the Juju VCA, call it. Then we use that Juju function to build essentially K8s across some set of VMs. And then we're putting OSM on top of that. So yes, the other services of OSM are now nicely operated on top of Kubernetes, and Juju isn't in what I showed you here. There really isn't any reason other than it's just work to have these things running on top of this, right? These things are essentially just Golang and Mongo, so easy to put on top of that. That's on the roadmap for the next 6 months. Kind of decide where you want to put it.
Yeah, but don't you have then a problem of bootstrapping? If you want to run the VCA on Kubernetes, but you're bootstrapping Kubernetes from the VCA, you can't.
Yeah, so you could use micro-K8s to build a Kubernetes, and you could put a different controller on top of this one. You could play with it in all sorts of ways. It doesn't really matter in the end. It's just software, and bootstrapping is always kind of hard. People will figure out, once you can figure out how to operate this and how to operate these and how to operate these, then it actually becomes very easy and you instinctively know what you want. In an edge type situation, I suspect we'll end up with MAS in the top of rack switch, maybe the VCA in the top of rack switch, essentially, and then just driving everything underneath that as either bare metal or VMs or K8s, and OSM, wherever it needs to be. I think we're getting now to the point where we have some nice operating primitives, and we can build either scalable Kubernetes clusters or non-scalable Kubernetes clusters. They're both actually quite useful. Mike had a really interesting idea that we could move those proxy charms, which are currently a bit awkward in the way we do them. We could move them actually to being proxy charms in Docker containers on a micro-K8. so that it'd be much faster to start them effectively. They'd feel like they were less work. Right now we have Kubernetes can do a lot of stuff for us, make it look easy. We could just use that effectively for the proxy charms that we have today. I think this will all clean up quite nicely. But ultimately, giving developers the ability to stand up OSM in a couple of minutes on their laptop, run it on an airplane flight, effectively completely disconnected, iterate on network functions. So on your own laptop, you build your Docker images of your network function, push those into the registry, which is running on microcates, use that from OSM effectively. That should all feel nice, clean, easy. Any other questions? Pretty exciting. And the Docker images that we're using for OSM, I believe, are the same standard Docker images that are being published today.
So
So there's a difference
basically,
between the Docker images. So.
basically it built release 4 images. Just those pushed to Docker Hub. So it's effectively the same thing CI builds every day.
That's a wrap.
Thank you.